When grounding an equipment ground on the secondary side of a 112.5 kVA transformer, the table listing circular mill should be used. The reasoning behind this lies in the connection of the equipment ground. It's connected to the transformer's neutral, which importantly is not protected by overcurrent protection devices. Because the neutral and therefore the equipment ground fault path does not have overcurrent protection, its size needs to be correlated with the transformer output and have a minimum size to ensure that it can safely carry fault current in order to operate an upstream overcurrent protective device during a ground fault. The circular mill table gives the minimum conductor size acceptable for the equipment ground. This minimum size is determined according to the transformer's ampacity. Now, regarding whether a transformer qualifies as a new service, a transformer is generally considered a new service if its purpose is to provide power to a newly constructed building or structure. In such a situation, the transformer installation must comply with the National Electrical Code, or NEC, requirements that apply to new services. The NEC mandates that the equipment ground must be connected to the transformer's neutral. Moreover, the conductor size for the equipment ground must be based on the ampacity of the transformer to ensure there is adequate capacity. Again, the circular mill table is used to determine the smallest permissible conductor size for the equipment ground, factoring in the transformer's ampacity. To find the ampacity of the transformer, you divide the kVA by the voltage and the square root of 3 if a three-phase transformer, or divide the kVA by the voltage a single phase. For example, a 112.5 kVA three-phase transformer with a 208-volt secondary is calculated as 112,500 divided by 208 volts divided by the square root of 3, yielding 312 amps. So if the transformer is 480 volts, then 112,500 divided by 480 volts divided by the square root of 3, yielding 135 amps. If the transformer is a single-phase transformer, the amperage is calculated as 112,500 divided by 240 volts, yielding 468.75 amps. These values are important to have because this is the value to base off of to determine the minimum size of the equipment ground wire. Consult the NEC table reference to correlate the overcurrent protection size and equipment grounding conductor size. In summary, firstly, for grounding equipment on the secondary side, use the circular mill table. Secondly, the equipment ground is linked to the neutral, lacking overcurrent protection. Thirdly, the circular mill table dictates the minimum conductor size based on ampacity. Fourthly, a new service involves powering a new structure, necessitating NEC compliance. Fifthly, the NEC mandates neutral connection and ampacity-based sizing for equipment grounds.